Welcome to FreeEduHub. Today we are covering another session on different models of cloud computing, and in that we have infrastructure as a service. Just to remind you, platform as a service and software as a service has already been covered in the course. This is our another chapter in the same series of the cloud computing. So in this chapter, we'll be covering the different aspects of infrastructure as a service, identify IaaS solution providers, then we'll define and describe the co-location. What's the meaning of a co-location in infrastructure as a service? Then we'll define and describe the system storage redundancy. What kind of storages are required in infrastructure if it is hosted in the cloud. Then we'll define and describe the cloud-based network attached storage. Network attached storages are available in the offices also. You might have seen it, which is used for the backup and things, but same kind of storage devices are available in the cloud which are used for your backup and stuff. Then we'll define and describe the load balancing and identify the cloud-based solution providers. How does it work and how can we get it? Then we'll describe some of the advantages and disadvantages of infrastructure as a service solutions. So if we'll see infrastructure as a service, many companies that deploy applications to the cloud will need to specific platforms such as Windows, .NET, Microsoft SQL Server, Linux, or Perl, or MySQL, etc. So it depends what kind of application you're hosting in the cloud, or what kind of website do you have. If you have any applications developed in ASP.NET, or you're using SQL Server, or your server requires Linux or Perl or MySQL database in the cloud. So it really depends what kind of service you want to avail in the cloud. For those companies utilizing a platform as a service PaaS solution, eliminate the company's need to administer the operating system and supporting software. So if we are relying on platform as a service, we won't be focused on the worries of maintaining the operating system and supporting software for that, licensing and all those other solutions for it. Other companies, because of the security needs or a desire to manage all resources, turn to IaaS providers. So all those problems were there in a conventional data center environment. That's why most of the companies are shifting towards infrastructure as a service. An infrastructure as a service provider makes all the computing hardware requirements or the resources available, and customer in turn is responsible for installing and managing the systems, which they can normally do for the most part over the internet. So what we are doing in infrastructure as a service is that we have a conventional data center in our office environment. Now if you don't want to host everything on premises where you'll be responsible for the backups, for the power, electricity, and all the related things which are required in order to run a data center, you can purchase a service in the cloud, and each and everything will be hosted in the cloud, including your server, its storage, its backups, its networking, cooling, uninterrupted power supply. Each and everything would be available in the cloud, and you will be paying for the services that you'll be getting from the cloud service provider. Now different data center capabilities are there when we host the things in the cloud. Now here we are further trying to understand infrastructure as a service, and we can see running a data center is an expensive and staff intensive process. To start, one must create a facility with the following capabilities. So if you want to run a data center, you must have experts in that field who are responsible for the data center operations. Means they'll be taking care of all the backups, the servers itself, changing the hardware, checking the hardware if there is any requirements are there, installation of operating systems, migration, upgrading the services, licensing, cooling, air conditioning, and then all the other things which are required in a data center. Now access to high speed and redundant internet service should be provided to the data center, just to make sure that all your customers around the world are able to reach the services. If you don't have a reliable internet connection, you might end up having some issues. And for example, if your internet connection is down and you don't have a backup connection or a redundant internet service provider, your customers will face a problem, because till the time your business is down, no one will be able to access your services in a conventional data center environment. Now, sufficient air conditioning to eliminate the heat generated by the servers and the storage devices. Since if we are running lots of servers, whether they are physical servers or virtual servers, they emit a lot of heat, and in order to control that, we have dedicated HVAC systems, which are the cooling systems in the data centers, which make sure that they are running in an optimum environment. Otherwise, you'll hear that your fans of the servers and the cabinets would be spinning too fast, and it would be too noisy in the data center environment. Same thing is there for the storage devices, switches, and other things which are installed in your data center. They emit a lot of heat, so in order to manage that, we'll have to make sure that we have proper cooling system available. Conditioned power with potential to uninterrupted power supply in the short term, and in the long term through the use of on-site diesel power generators. So when we are talking about maintaining a data center within our environment, you'll have to make sure that you have power supply which is uninterrupted, and in case if the power goes down, we'll have to use UPS, which is depending on the size of the servers that you have. The smaller one could be from 10 kVA to 20 kVA and more, depends what kind of setup you have. The third thing is that most of the companies have the diesel power generators, which are usually installed at the outside, somewhere outside the building, so that in case in future if they want to shift their complete load to the external power source, they'll be able to do it. Now keep in mind that uninterrupted power supply, which we call as UPS, they have a certain hours of battery retention period. After that, once it's exhausted and still the power is not restored, you'll have to shift to the diesel power generator so that your data center is up and running. And especially in nowadays, when we know that we have IP telephones, we have IP based cameras, if we have IP based devices in the organization, if one thing goes down, the entire infrastructure would be affected for that. Then we must have a fire suppression systems as well, that in case of a fire, what kind of equipment should be available in the data center. Of course, we cannot use water in the data center, it would affect the hardware. We'll have to use the suppression agents or the kind of foam and gases, etc., that would help us in getting rid of the fire in case if there is a problem like that. Administrative staff is required to support the hardware, network, and operating systems, who are dedicated for those things, who are taking care of the hardware, networking, and the operating systems which is there installed on those systems. Now in this next diagram, we are just covering a snapshot of a typical data center environment. As you can see, there are some servers over here which are running, and then we have some storage devices connected to this one, and we have maybe a UPS connected over here, and the rest of the storage devices and networking, etc. The picture is quite old. We are not using this kind of equipment anymore. You can identify it by the color of it. It's quite outdated picture, but due to the security reasons, it's never recommended to share pictures of your actual data centers, with the help of which, if anyone can get some details about the kind of systems you are using in your data center environment. Now, reducing a single point of failure through co-location. Single point of failure means that if everything is dependent on a single node, and if that node is disconnected, you'll have no connectivity at all. To reduce the risk of single point of failure, companies often create a duplicate data center at a remote location. So they can have a duplicate data center at a remote location, but it would cost them a lot. Should one of the data centers fail, the other data center can immediately take over the operation. So it is constantly keeping the backup of the primary data center to the secondary data center. It means that both data centers are working and they are constantly creating a replica of each other. Unfortunately, the second data center will increase the company's cost, essentially doubling them, because there are duplicate servers, storage, networking, internet access, and staffing, etc. Now, when we are talking about a co-location or a backup site that we are maintaining, if you're doing any sort of certifications, there are different kind of it, like cold site, warm site, and a hot site. A cold site would be there that you know that if something fails, you have a place where you can set up your operations, but nothing is configured over there. You'll have to configure everything. You'll have to install the operating system, servers, and each and everything. but the space is available where from where you can run your operations. Of course, it would take some time to set up that thing and to work on it till everything is up, you have restored the backups, and then it would start working. The warm side is that it has the air conditioning, it's off, it has the servers, they are not configured, or the data is not up to date, operating system is installed, but it is in the powered off mode. So you'll have to power up everything, restore the backups, make sure that the cooling is enough, it is covering the kind of heat dissipation from the servers, and then it would start running. Of course, it would take less time as compared to a cold side, because at least the operating system and rest of the basic configurations were there. You'll have to just restore the data from the backup and run the services from there. The hot site is a site which is 100% functional at a remote location, which could be in the same city, it could be in a different city, but it is recommended to have it in a different cities, because if God forbid due to any natural disasters, if one city is affected, the other city is at least functional and they are working. So that's the same kind of setup that we have in the clouds. When we are signing up for a infrastructure as a service in the cloud, it asks us for a primary location which could be in your area and a remote location which could be in anywhere else in the world, so that if anything goes wrong in one geographical region, you'll still be able to run your operations from the second geographical location. Now, infrastructure as a service, as a data center, larger companies or companies with specific server needs, in contrast, may require their own independent server hardware data storage services. For example, situation infrastructure as a service is ideal. Sometimes it's a policy, it's a compliance or a regulatory compliance policy that you'll have to keep the record of specific things within the geographical region or within the country. So in that case, you'll maintain your databases on premises, and the rest of the things can be available in the cloud, where your servers will be able to reach your storage on premises. An infrastructure and a service solution provider, a customer with its own hardware resources. You can think of a IaaS as a provider of a mini data center with a large data center facility. Most infrastructure as a service providers house the data centers for multiple companies, so different companies would be able to access their cloud using their own servers, virtual servers in the cloud, but the data of each customer would be maintained in a way that one customer cannot see the data of the other customer, and of course there is proper encryption method enforced on that. Now it's up to the company that what kind of encryption mechanism they are choosing for it, but it keeps the data completely separate from the other customer. Most infrastructure and service providers house the data centers for multiple companies. Because of infrastructure and service providers spreads the cost of the power, air conditioning, file suppression, and the staff across multiple customers, it can normally offer a pricing that beats what each individual company would have to pay for its own facility costs. So whenever we will compare the cost of a data center which is in the cloud compared to the data center that we have on premises, there is no match on that, because we'll have to pay an annual fee or a monthly fee to the administrators, then we'll be paying for the electricity charges, we'll be worried about the networking, the security of the data centers, backups of the servers, and all the other things which comes in with the servers itself. The other thing is, which is a very big selling point for these cloud service providers for infrastructure as a service, is that they are constantly upgrading their infrastructure for the latest hardwares and things, so you don't have to worry about spending a lot of money on buying new servers or upgrading them or paying the licensing fee and all those things. They'll give you a price bundle which everything is included in it, so that you don't have to worry about all that recurring costs which are there associated to the on-premises data centers. Further, just as SaaS and PaaS, as we covered earlier, infrastructure as a service solution is no different. The customer pays only for the resources consumed. Simply put, infrastructure as a service solution provider, the least expensive and the fastest way of the companies to launch the data center at a co-location or a facility. Now that's showing the infrastructure and its server as a data center, where different data centers are available dedicated for different customers in the cloud. Now we are covering the improving the performance or load balancing in the cloud over here. As you know, there are lots of famous websites, for example, Google, Yahoo, Amazon, Microsoft, etc. obviously experience tens and millions of users hits per day. Now, to handle such web requests, the sites use the technique used, which is called a load balancing, to share the request across multiple servers. So there would be multiple load balancers. They'll be taking care of the traffic which is coming from different geographical locations, and then it would be distributing the load among different servers. It's not like if one server is overwhelmed with the resources, only then the second request would go to the other server. It would keep on distributing the data among the servers so that all servers are performing at an optimum load. And of course, the administrators who are sitting in the back end, they are constantly monitoring the performance of the servers and the traffic which is coming on that. If it's required to host more servers in the cloud in order to serve the needs of everyone, they'll do that so that the customers would have an excellent experience when they are browsing their websites. Now, when we talk about improving the performance and load balancing, we can see that that's how it is actually sharing the response. If a user asks for HTML page or a graphics or a CSS, Cascade Style Sheet, or a JavaScript, it would be served from these servers to the remote computers. Now here we are trying to understand the managing the data with load balancing. A user is there which is requesting something. It would go through a load balancer. The request would be there. A server and a database one is there, and then there is a second one, server and a database. So there are multiple kind of backups that you can maintain, that a database update is constantly being maintained on another server for the primary server where the data is going. When demand becomes too great for the server, the company can place a load balancing server in front of two or more servers to which the load balancing distributes the web services. So it would keep on going to one server. If it would see that it's heavy, it would transfer it to the other one. But the previous technique that we saw, that it is distributing the traffic equally to the servers, is still the most successful, which we call it as a round ribbon service as well. To eliminate a single point of failure, companies will often replicate copies of the databases on multiple servers. The database software in turn must then synchronize the data and update it across different systems. So as they are explaining, you can have a server and a normal web server or an application server and a database server over here. The primary one would be used, but it would be constantly maintaining a backup in the same cloud with the same cloud service provider, maybe at a different location, maintaining the backup of both server and the database which is used over there. Now we are talking about replication and load balancing using cloud-based NAS database, which we call it as network attached storage. An alternative to the company may choose to simplify the solution using the cloud based database or a cloud-based network attached storage device. In this way, the applications do not need to worry about the data synchronization and replication. The task is handled within the cloud. Now as you can see, through a load balancer, the request is coming to the server number 1. It would replicate it within the cloud to the server number 2, as we explained earlier. Now we are talking about DNS functionality over here. The functionality of a DNS is, as we know, DNS is domain name server, or it is maintaining the records of the entries. For example, if you would request to go to yahoo.com, you'll request your DNS. DNS is maintaining the entries for Yahoo, and as soon as you'll pass the query, it would send you the IP address, which is the IP address of Yahoo or MSN or any other website, and the website is served through your DNS server. When the load balancer receives the browser request, it simply sends the request to one or the two servers in a round robin, which demands on-site to increase the additional servers can be added, to which the load balancer can distribute the request, similar to this technique as most IaaS service providers are using it and scaling it for load balancing. as I told you in the previous slide, that that's a round ribbon format through which it is making sure that the requests are going distributed to different machines simultaneously. Now, when we talk about DNS functionality, we'll have to take care of our DNS servers also. There is a technique, or there is a problem through which they try to penetrate in the DNS servers. It's called DNS poisoning, where they will poison the DNS tables or root tables, where it's maintaining all the records of the websites which are known to a company, for example Google and Yahoo, or the services which people are availing from your office premises. Now, this happens in the case because most of the people who are using these services, they will go to the DNS server and it would serve them for the things which are available, or the records for them is available in the DNS server. If it is poisoned, it would redirect them to a lookalike website of Yahoo, MSN, or Google, or Gmail, etc. And the user would be redirected over there, where there will be a man sitting in the middle who will be capturing all the username and passwords which are sent to these users through these services. Now we'll see the concept of co-location. One of the greatest benefits of cloud-based companies is that it does not matter where the physical computing resources and data storage devices are located. As a result, the companies often employ duplication of the off-site servers or the disk storage devices through the process known as co-location. So, as we discussed earlier, it would be available somewhere. You don't worry about it where it is located, but in case of a failure, it would automatically shift to your second co-location, and the services would be operated from there. By employing duplicate resources, systems can fail over from one location to another, or can use the duplicate systems for load balancing. As you can see that in case of a failure, it would shift to the other one. Why to use a co-location? One of the greatest benefits of a cloud computing is that it does not matter where the physical computing resources are. By applying duplicate resources, systems can fail over, make a company less susceptible to fire, disaster and terrorism. It can improve the performance through the distributed workload, and the company can avoid any kind of downtime due to the power loss or the blackout or burnout, etc. Now, the cloud storage for the data replication. As you can see that the user is maintaining everything in the cloud, in a cloud-based NAS, which is network attached storage, or a cloud-based database where the data storage and a redundant data storage is there. Likewise, there will be a duplicate of the database, and the backup of the database will be maintained in the cloud. Now, next is cloud storage. If we are using anything like Dropbox or Google Cloud Services or any other cloud services where we are maintaining the backup, that's a cloud storage. One of the most innovative disk storage solutions utilizes the cloud-based network attached storage, which represent the devices to the users and applications as mountable devices, and the file systems. It could be FTP, it could be CIFS, it could be network file sharing, and we can save our things in the cloud. Normally, customers can use or scale their cloud-based storage on demand, paying only for the storage that they consume. Now, if you know that in Office 365, they are providing OneDrive through which you can store lots of things in the cloud, and there are, of course, lots of advantages of it. Now, as you know, Dropbox is an excellent utility which is not only giving you a storage in the cloud, it is automatically synchronizing your data from your host computer to the cloud as well. So, if you have defined that you want to back up your desktop and documents where most of the time you're saving your documents, or if you have selected a directory on your computer, it would back up that thing regularly in the cloud, so that in case of a disaster, at least your data is saved on the cloud-based storage. Not only that, you can even mount that drive on your computer. So if you'll go to this PC with your other partitions, you'll see this partition of your data which would be attached to your computer, so that conveniently you can copy the files from there, save the files in it, and it would be automatically saved in the cloud. Now, there are lots of advantages of infrastructure as a service. It eliminates often expensive and staff-intensive data centers, ease of hardware scalability, reduce the hardware cost, on-demand pay as you go, like whatever you need, you'll be paying for that only, reduced IT staff, and then suitability for the ad hoc test environment. It allows complete system administration and management through the web-based interfaces. Now, infrastructure as a service where the server types are there of different kinds. We divide them into a physical server, dedicated server, or a shared virtual server. Within an infrastructure as a service environment, customer may acquire one or more servers. These servers can fall under one of these three types. Now, physical server is actual hardware allocated for the customer, dedicated for use. That would be the only server you'll be using. No one else will have any access to that. You can install whatever you want to install on it. You can restart it. You can shut down whatever you want to do it. No one will be responsible for that, and others businesses will not be affected by it because that's only dedicated for you in the cloud. A dedicated virtual server is allocated to the customer running on a physical server which may or may not have any other virtual server. So that would be a server which would be a virtual in the cloud, but maybe it would be infrastructure as a service. So maybe it would be only your server, or maybe the other server would be there which is hosted on the same host. But regardless of that, if it is dedicated for you, it would be your own server only. Shared virtual server is a customer access to a virtual server or a device that may be shared with other customers as well. Now, as an infrastructure as a service physical server solution allocates one or more physical servers to the customers, the server will be shared with the other customers because it is shared by others. It will be more expensive. However, the customer will have complete control over the system. It's because it is not shared with the other customers, it would be expensive. Because it is your own server, it's not like a shared hosting service where you are hosting your website with the other customers. So you cannot make the changes that you want to make, because if you make the changes, other customers will be affected as well. So if it is a dedicated server for you, it will be expensive as compared to a shared server. A dedicated virtual server solution allocates to a customer one or more virtual servers that has a special software installed to run to multiple operating systems, which may not have to be the same. So it is up to you what you want to run on your virtual instance. Since it is your dedicated virtual server, you can do whatever you want to do. Sometimes we don't go for a shared hosting because we have certain applications which you have purchased, or you want the application to run in a specific way and you have some special configurations for that. You'll go for a dedicated virtual server to host your services in the cloud. Each operating system is protected from others on the server and can often be configured by the customers. This virtual server is used by one of the customers, which again will result in a slightly higher price per month as compared to a shared server. A shared virtual server solution allocates a shared virtual server to a customer. The server may be, for example, provide web server capabilities, and multiple other users will be accessing it at the same time. The customer cannot configure the virtual server, but you will be able to transfer the files for your website, which is pre-configured, and it would be working the same for all customers. Now here, as you can see, there is a physical server which is only for you. You can manage it. If it's a dedicated virtual server in that, or you can say a dedicated virtual host, you can have multiple different operating systems in that. Maybe you want to install an instance of Windows or Linux. Whereas if it's a shared virtual server, it is shared amongst different customers. So you cannot make any changes to this one. It would be taken care of or managed by the cloud service provider. So that was our lecture on infrastructure as a service. That's it for today. Thank you very much.